Welcome back to Hardware Unboxed. Today we're going to be exploring storage performance, a topic that we don't often cover on the channel. We're not really storage reviewers, we don't have a ton of interest in benchmarking SSDs, but there are a couple of questions that I've been wanting some solid answers to, so today we'll be getting into a bit of that. This video has also been in the works for quite some time. It's taken months to get the right drives on hand for today's video, so a shout out to all the companies that provided drives for this video and have been waiting a long time ever since. So what I want to look at in today's video is what sort of storage device do you need to play today's games? Specifically, what sort of drive provides the best loading times so you're not sitting around and waiting ages to get into gaming? Part of this answer is a bit obvious. Everyone at this point knows that SSDs are faster than hard drives, so I want to dial down a bit and see what sort of SSD is required. Do you need a PCIe drive? Do you need something with a DRAM cache? Are certain memory technologies worse than others? We'll answer that today. I think this video will also serve as an interesting point to look back on as we move into a new generation of game consoles. Up until now, most games have been built with hard drives in mind, but with new consoles featuring super fast PCIe SSDs, the storage requirements for games may change in the coming years. We'll be able to look back on this testing to see just how things have changed. The setup for today's video is simple. We'll be loading up a variety of games and timing how long it takes to get into a playable level from the main screen. Loading screens are the primary thing impacted by storage performance in games. Everyone wants to get in and play games immediately, so we'll be testing that across a selection of different titles. As we have some PCIe 4.0 drives in today's storage suite, we will be using our AMD Ryzen test system. It's kitted out with the Ryzen 9 3900 XT for today's testing, along with an MSI X570 Tomahawk motherboard, 16GB of DDR4 3200 dual channel memory, an NVIDIA GeForce RTX 2080 Ti because Steve is hoarding all our RTX 30 series GPUs, and it's built inside this nice Corsair case. The storage setup sees the system running off an M.2 drive in the second slot, with our games for testing running on a separate drive in the primary M.2 slot, which has direct links to the CPU. Let's work our way through the drives we'll be testing because I have 14 different options on hand. Representing Team Hard Drive in today's battle is the Western Digital WD120 EMAS 12TB model. This is a standard OEM drive used for archival storage with a 5400 RPM speed, 256 megabytes cache, and SATA 6 gigabits per second interface. We're fully expecting this guy to be pretty slow. Team SATA SSD has three contenders. Our entry-level model is the Team Group GX1 500GB, which uses SanDisk TLC NAND, a Phison S11 controller, and does not feature a DRAM cache. One step up is the crucial MX500 2TB, which packs Micron TLC NAND, an SMI SM2258 controller, and a DRAM cache. Then for the big data hoarders, we have the Samsung 870 QVO 8TB with Samsung's QLC memory and controller, along with an 8GB DRAM cache. For more specs on all of these drives, of course, you can check out detailed reviews or spec pages. We have lots of PCIe 3.0 x 4 SSDs for today's testing as well. From Western Digital, we have both the WD Black SN750 and WD Blue SN550 in 1TB capacities. Both use SanDisk TLC, but the SN750 has a DRAM cache, where the SN550 does not. You'll also spot this pre-installed heatsink on the SN750. ADATA has provided their XPG SX8200 Pro 1TB model, which has an SMI controller and TLC NAND from Micron with a DRAM cache. So this is an alternative to the SN750 with different components. We also have the Sabrent Rocket 2TB, a popular option that uses the Phison E12 controller and Toshiba TLC NAND with a DRAM cache. Then rounding out our PCIe 3.0 offerings are two QLC drives. The first is the Intel SSD 665p in a 1TB capacity, which uses an SMI SM2263 controller alongside Intel's own QLC memory. Then, as an alternative solution, we also have the Sabrent Rocket Q 2TB, which features a Phison E12S controller and Micron QLC NAND. Both drives also feature DRAM caches. Then we have three PCIe 4.0 drives, all of which use essentially the same design. The Seagate Firecuda 521TB and Corsair Force MP600 1TB both have TLC NAND from Toshiba and Phison E16 controllers. The Sabrent Rocket 4.0 2TB is similar, but with a larger capacity. And last but not least, we have an SSD with a USB interface, the Samsung T5. This drive features USB 3.2 Gen 2x1 and TLC memory from Samsung, along with, as you might have guessed, a Samsung controller. There's also a DRAM cache here, as is the case for the PCIe 4.0 drives I was just talking about. Before getting into the game data, let's run a single synthetic workload, Crystal Disk Mark, to see what the numbers say. This is a typical workload you might fire up on your new SSD after you get it to see those super high numbers. So how do these drives stack up? For sequential reads, it's a pretty simple story. At the top with 5 GB per second transfer speeds are the PCIe 4.0 drives. All of the PCIe 4.0 drives are in the range of 30 to 40% faster than the next group of higher-end PCIe 3.0 drives for performance. One step down from that are the more entry-level PCIe 3.0 offerings, such as the SSD 665p and SN550. Then we see the SATA drives, capped to around 550 MB per second sequential reads, and the hard drive comes in last. Generally, the difference between a PCIe 3.0 drive and a SATA drive is that the PCIe 3.0 model has up to 7 times faster sequential reads. For sequential writes, the story doesn't change too much either, although this is peak performance from writing into those DRAM caches. Things do get more interesting when it comes to random performance, although at high Q depths, there is still an advantage going PCIe 4.0 over 3.0. The QLC-based PCIe 3.0 SSDs deliver the least impressive performance here, less than half that of the better TLC models. SATA SSDs also suffer, offering just a quarter of PCIe 3.0 performance in the best cases. Of course, for single Q-depth random reads, there isn't much separating a lot of these drives, except for the hard drive, which is very slow in comparison to even the slowest SSD. Here's the random write performance as well. While writing random data isn't as strenuous as reading it for some of these drives, SATA models do suffer again with just 1/5 the performance on offer. So that's a quick look at the synthetic numbers. Based on this, it looks like PCIe 4.0 drives are clearly the fastest in this test, followed as expected by the higher end, then more entry-level PCIe 3.0 drives. These NVMe options are then much faster than SATA drives, often 4 times faster or more, with the slow mechanical hard drive rounding out the group, with performance that's particularly bad for random reads and writes. But does this matter for game loading? Well, let's find out. I want to start here with Horizon Zero Dawn, one of the most resource-intensive games you can play on PC today. However, for load times, it's not hugely dependent on storage performance, at least when you get into the SSDs. The slowest SATA drive, the Samsung 870 QVO, offered a 73% speed up to load times versus the hard drive, so it's clear that having an SSD is important. But beyond that, there's just a 36% improvement moving from the slowest to fastest SSD tested. For loading Horizon Zero Dawn, there is no clear advantage to having a PCIe 4.0 drive over PCIe 3.0. Despite the 4.0 drives putting in, say, 30% better read performance in Crystal Disk Mark, when loading this game in the best case, the 4.0 drive was 2 seconds faster than the slowest 3.0 drive. At a 15% speed up, that's on the minor end of the scale, and that's comparing entry-level PCIe 3.0 in a drive like the SN550 to the top-end FireCuda 520. There is a small gap between the SATA/USB and PCIe 3.0 drives. On average, the non-PCIe SSDs loaded in 21 seconds compared to 17 seconds for the PCIe-equipped models. That's a respectable 24% improvement, but it's not nearly in line with the huge differences in synthetic workloads. We're talking drives that can pull 2 GB per second reads easily versus a cap of just 500 MB per second for the SATA models. That doesn't really materialize when loading games. The difference is even less pronounced in Death Stranding. There was just a 2-second difference in load times between the fastest and slowest SSD models. Yes, there is a tendency for the SATA drives to be slightly slower, but this is a marginal difference. It's hardly worth talking about. Even the hard drive does reasonably well in this game, loading in just 22 seconds. In Shadow of the Tomb Raider, again, just a 2-second difference between the fastest and slowest SSDs. So in this case, up to a 15% gain going from an entry-level SATA drive to a blazing fast PCIe 4.0 option. It's also clear from the testing so far that having a DRAM cache, as expected, plays little to no role in game loading or read performance. The DRAM-less SN550 is one of the faster models for loading this game. However, it's clearly better to have at least some form of SSD for loading Tomb Raider. Loading from a hard drive was more than twice as slow, and while overall load times aren't terrible on a hard drive, a simple speed up from an SSD is worthwhile. Red Dead Redemption 2 is one of the slower loading games in our test suite, which is why we chose to use it. However, these slow loading times do not appear to be as a result of storage bottlenecks, at least with an SSD. Most drives loaded this game in around 40 seconds, with a negligible difference between loading from a SATA or PCIe drive. However, it is worth having an SSD, as you'll shave 23 seconds off the load time versus a hard drive. Borderlands 3 is an interesting case, as we're looking at the loading time for both loading into the level and then waiting for the assets and textures to load in. When loading this game, you'll often have to wait a few seconds for everything to be fully rendered. Despite this, the game doesn't appear to be storage limited during this process, as all SSDs took between 17 and 19 seconds to load the game and its assets fully. In fact, nearly all of these drives loaded into the level within about 11 seconds, and then there were some small differences in texture loading times. In any case, with some of the entry-level SATA drives performing well, and say the Sabrent Rocket 4.0 being not quite as quick, it appears the engine is more to blame for loading than the storage you're loading from. This is another game where I didn't see a huge speed up coming from a hard drive to SSD either. Yes, SSDs were noticeably faster, but not to the extent of a game like Horizon Zero Dawn or Shadow of the Tomb Raider. The Outer Worlds was a game I chose to test because it has a lot of loading screens. Luckily, if you're playing from an SSD, loading shouldn't be that painful, as it was one of the quickest games to load that I tested. However, it only appears to require an SSD to be fast, not any specific sort of SSD. Once you have solid state storage at hand, there is only a 1 second difference between the fastest and slowest models, and there was no preference for PCIe over SATA. It was a bit of everything. One thing is clear though, get an SSD for playing Outer Worlds, as they are more than twice as fast for game loading versus a hard drive. Playing this game off a hard drive would get pretty frustrating, constantly having to put up with 25-second load times when you could be loading in as low as 11 seconds. Assassin's Creed Odyssey, loading into the heart of Athens, is another title where your choice of SSD doesn't really matter. PCIe drives were on average just 7% faster than non-PCIe drives for loading into the game, which is a pretty negligible difference. And there was no clear advantage to PCIe 4.0 drives at all, with the additional speed of those models providing no benefit. However, like with Outer Worlds, loading this game from a hard drive is much slower, 2.5 times slower to be exact, so it's definitely worth having an SSD for loading this game. Next we have loading into The Division 2. In this game, we're looking at loading with all textures rendered, with the time taken from after the game connects to live services to the final textures being loaded. This title behaves more like Horizon Zero Dawn in that there is a small but more noticeable advantage to some SSDs over others, and having faster storage can speed up your entry into the game world. The differences aren't huge though. An entry-level PCIe 3.0 SSD like the SN550 is less than 10% faster than a value champion like the Crucial MX500, and some of the faster PCIe drives load the game fully around 20% quicker than the more entry-level models. There is a 6-second difference between the best and worst SSDs, but we're still well off some of the results we saw in our synthetic workload from earlier. Still, there is a moderate improvement moving from a hard drive, so I suspect most gamers will want to play this game on an SSD like the others we've been looking at. The final game I wanted to check out is Planet Coaster. The reason here is that loads into simulation games with large game worlds is known to be particularly slow across pretty much all of these sorts of games. So whether you're loading a big theme park or a big city in a world building game, you can expect load times that take multiple minutes. However, what's really important to realize is that these load times are not due to slow storage speeds. When loading a huge Planet Coaster park, generally the game took at least 6 minutes to load on my 3900 XT system, with a 26-second difference between the fastest and slowest drives. But as you'll see here, there's really not much of a difference between a hard drive and SSD for loading this game, and only somewhat of a tendency for faster PCIe drives to outperform slower SATA models, although even that isn't guaranteed all of the time. What we end up getting in Planet Coaster is a bit of a muchness. There's a 7% difference splitting the fastest and slowest drives, which when you're having to wait over 6 minutes even with a super fast PCIe 4.0 SSD, isn't really worth talking about. The simple fact is that in these sorts of games, there is far more processing work that goes on when loading a level than there is copying from storage into system or GPU memory. It's much more important to have a fast system overall for loading than it is having a blazing fast SSD, and I wouldn't go upgrading your drive to get faster loads in games like these. It just won't happen. After working through all of this data, I don't think there are too many surprises in here for PC gamers. Most people in this community would already know that if you want to improve loading times for your games, upgrading from a hard drive to an SSD is a no-brainer. In all instances, the hard drive was the slowest storage device for loading, and in many cases, upgrading to even the slowest SSD led to games loading in half the time. Hard drives are fine for archival storage for games, but moving the game you're currently playing to faster storage makes a lot of sense. However, what has become blatantly clear from this testing is that It doesn't matter what sort of SSD you have for gaming, so long as you have an SSD of some sort. In 6 of the 9 games we tested, there was only a 2-second difference in load times between an entry-level SATA SSD and the absolute fastest PCIe 4.0 drive. In percentages, this was usually below a 15% performance uplift, moving from the fastest to the slowest drive, which is hardly worth talking about. In the best cases, like Horizon Zero Dawn and the Division 2, even then it doesn't really make sense to go all out on a high performance drive for gaming. I did see up to a 35% speed up for load times, moving from entry-level SATA to super fast PCIe 4.0, but what we're talking about in raw numbers is the difference between waiting 21 seconds and 16 seconds. Right now, even the best SSDs don't offer an instant game load experience, so for many buyers, I don't think it's worth paying quite a large premium to shave off just a few seconds to load times. There's also very little difference between different SSD specifications. PCIe 4.0 versus 3.0 provides essentially no benefit in most cases, especially compared to a top-end PCIe 3.0 drive. QLC memory is not slower than TLC for reading game files. Having a DRAM cache is also not important for game loading. The only specification that has some influence is whether the SSD is SATA or PCIe, with SATA being slightly slower, but beyond that, other specs are rather meaningless for gaming. Why don't games benefit all that much from faster SSDs? Well, it seems pretty clear that storage performance is not the main bottleneck for loading today's games. Pretty much all games up to this point are designed to be run off hard drives, which are very slow. After all, the previous generation of consoles with the PS4 and Xbox One both used slow mechanical drives to store games. Today's game engines simply aren't built to make full use of fast storage, and so far there's been little incentive to optimize for PCIe SSDs. Instead, the main limitation seems to be things like how quickly the CPU can decompress assets and how quickly it can process a level before it's ready for action, rather than how fast it can read data off storage. While choosing an SSD for gaming is pretty easy based on this data, there are some extra elements to consider, so here's where I'd end up with my recommendations. If you are planning to play games off a secondary SSD in your system, so separate from your boot drive, buying an SSD for this task is super straightforward. You're going to be better off buying, say, a cheap SATA drive with a high capacity. It's much more preferable to have more storage for games than it is to get a slight performance uplift from PCIe, and this is where SATA drives excel. With that said, in today's market, there often isn't a huge difference in price between, say, a cheap entry-level PCIe M.2 SSD, like say the Intel SSD 665p, and a cheap SATA drive. An entry-level drive like this SATA model from Team Group in a 1TB capacity is only often $20 to $30 cheaper than, say, we've got over here the WD Blue SN550. So when you're tossing that up, it's not too much of a difference. Where that gap extends though is in the high capacity range. 4TB drives such as the Samsung SSD 870 QVO, as my Sabrent rocket falls over, is much cheaper than you'd get from a 4TB PCIe model like the Sabrent Rocket Q, which actually is this model right here. So this drive on my hand here, 4TB, is going to cost you about $500 US. The Sabrent Rocket Q 4TB is going to cost $750. In this capacity range, it makes much more sense to buy something like the 870 QVO with its SATA performance. The one caveat I'd make to this recommendation is that some drives are much slower to copy data to than others. QLC-based drives like the Samsung 870 QVO or the Intel SSD 665p that we've got here can be slow to write to once you get beyond their DRAM or SLC caches and you're writing directly to the QLC memory. If you're going to copy games in and out of storage a lot from another fast source, it might make more sense to avoid one of these QLC-based SSDs and stick with a TLC option. But this likely will be more expensive though, and QLC is still a great choice for an archive type SSD that you're going to play games off of. If you're going to have just one drive in your system that doubles as both a boot drive and a gaming drive, I'd make a somewhat different set of recommendations, because in this situation you're not just game loading that you're worrying about, but general system tasks and, well, things like app loading. While we didn't really cover anything other than gaming in this video, I think it's still important to talk about briefly. As a boot drive, it is worth paying a premium for PCIe 3.0 storage, especially given current pricing for 1 to 2 terabyte drives, where PCIe doesn't cost that much more. Specifically, I'd be after something with a DRAM cache so you get that nice peak write performance, so probably not the WD Blue SN550, and I preferably want TLC memory as well to avoid some of the performance shortfalls of QLC, but I wouldn't be going out of my way to get anything higher end than that. In a gaming focused build, it's really not worth paying for PCIe 4.0 storage yet, or any of the professional focused drives with high-end controllers like, say, Samsung's Pro line. Pricing may vary depending on the retailer you're looking at, but something like the SX8200 Pro or the WD Black SN750, right around the mark of good value here, with both often around $130 US. The Sabrent Rocket, you'll see some of those there. They've also been quite popular at times. These drives are around $25 more at 1 terabytes than their DRAM-less or QLC-based entry-level competitors, but as a boot drive, I think it's worth spending that extra cash, whereas for a secondary drive for gaming, I wouldn't say it's worth it, but in general, do your research on what's available and at what specifications. But you might be shouting or angrily typing into the comments right now, what about this next generation of gaming? Don't the PS5 and Xbox Series X pack powerful SSDs, which will make SSD performance key for gaming? That's definitely a possibility, but we're likely talking about several years down the track. APIs like Microsoft's Direct Storage, which is designed to mimic the storage capabilities of these new consoles, has only just been released for developers. Like with all technology transitions we've seen, one prior example being DirectX 12, it'll be several years before we start to see these things harnessed in cross-platform titles on PC. With that in mind, and with the high prices for PCIe 4.0 storage, I don't think it's worth buying a fast SSD now and waiting for performance to be utilized in games. Because we aren't seeing any benefit today. You could be waiting a few years, and in that time, PCIe 4.0 drives will likely become a fair bit cheaper. So I'd say it makes more sense to buy an SSD that's capable today, again, something like this, than it is to buy a PCIe 4.0 drive, and then I would think about upgrading to something faster when games start requiring it and those drives become cheaper. So that's it for today's storage investigation. As you can see, lots of drives here in front of me. You've got MX 500s here as well, Sabrent Rockets, all sorts of stuff, and even trusty hard drives, which we still like, perhaps not for loading games from, but they still can be a useful integration into your PC if you're interested in, getting a bit of high capacity storage for cheap. So anyway, lots of storage that we've gone through today. If there is anything else you want us to use all these drives for testing, if you want to see other sorts of testing done with SSDs, we've got a whole bunch of them in hand now. So let us know in the comments below if you're interested in seeing more storage testing. It'll be interesting swapping all those drives in and out again. Anyway, if you're interested in supporting our testing as well, we have our Patreon page. Links to that are in the description below. You get access to our monthly live streams, behind the scenes videos, Discord chat, all that sort of thing. Subscribe for more, and I'll catch you in the next one.